Hi, student friends. Good afternoon to all. I welcome you all in this our fluid mechanics lecture. So, in this session, now we are going to finish this unit. Let us learn the remaining points from this unit. The next point here that we are going to learn is about the equation for finding the time required to empty the reservoir or tank with rectangular weir or notch. Okay, so write down their title about this. Time required to empty a reservoir or tank with rectangular weir or notch. Okay. The derivation of this particular point, it is similar to the derivation of orifice as we have derived there. There also such kind of one point was there regarding finding the time required for to empty the tank with an orifice. Okay, so we have derived the equation there in the same way here also, but here instead of orifice notches are there. Okay, and with the help of notch, how much time it will take to empty the tank or reservoir? That point we are assuming. So for that purpose here, let us define some terms here. Let's capital L be the length of the crust here. Okay, rectangular crust. We are talking about rectangular weir, right? Let this is the crust L, length L. CD is the coefficient of discharge. H1 is the initial height of water liquid, height of liquid above the crust level. Okay, suppose this is the notch here, rectangular notch. The initial level, let us say this is the H1 level here. Okay, this is H1, and H2 is the final level. Means let us say at this point, this is the H2 level. So how much time it will take to reduce this level from H1 to H2? ही level इथून इथपर्यंत येण्यासाठी किती वेळ लागेल? That is nothing but capital T. And here we are going to derive this equation for finding this capital T. That is time required to lower the height from H1 to H2. Right? This is the derivation. T is the time required in seconds to lower the height from H1 to H2. So for this purpose here, what we do? Let us consider here small strip here in that particular weir or not, as it has been shown in the diagram here. Diagram has not been drawn here. So for reducing the height by reducing the water level by height dh. Let us say this is the L and this is the dh is the height. H2, H1 height is here, H2 height is here, and this is the dh. So to reduce this height dh by depth dh, let us say time required is dt. Okay, dt time is required to reduce the height by dh. Then how much volume of water will flow when the liquid is lowered by this height dh? So that will be nothing but dh into length. You will get here the area, dh into the cross section area of the this tank का जो cross section area है, that cross section area multiplied by this height, you will get the volume of water removed or went away within the time dh. Okay, let the liquid surface fall by dh, then minus ADH is the volume of liquid went out. Minus sign has been put because the height is reducing here. Okay, minus ADH or volume of water is reducing. It must be equal to the discharge which is taking place through this notch into dt. Okay, within that short duration of time, the rate of discharge is this q. Okay, q is nothing but it is the volume upon time, right? This time into time it will get cancelled and you will get the volume here. So the discharge, that this volume, it must be equal to this volume, which is obtained by using this discharge. Okay, and for the rectangular notch or weir, the formula for finding the discharge is 2 by 3 CDL into under root of 2G into H raised to 3 by 2. If I put this value here inside this equation, I will get this equation. Okay, left hand side will be as it is, and to the right hand side, this part will come into dt. Now we are interested in finding the time, right? Capital T. So what I will do, I will take this dt on one side and all other things on the other hand side. Okay. So I have taken here, I have taken this part here on the LHS. Then I will get this equation like this. dt is equal to this thing I will get, right? And then now here dt is the short duration of time, but I want how much total time is required, okay, to lower the height from h1 to h2. h1 पासून ते h2 पर्यंत हाईट जाण्यासाठी किती वेळ लागला? So for that time capital T, okay, so that dt I will integrate between the limit 0 to capital T. So this is the total time T required to change the height or to lower the height from h1 to h2. So here I will apply the integral for the time from 0 to t, and for here height h1 to h2. Now here if I do the integration of this dt with t, I will get here capital T. Okay, and here on the RHS on the right hand side, if you see there, some things are constant there. That constant things we will take out. In the numerator, this is the constant. In the denominator, these things are the constant. So if I take it outside the integration side, what will remain here? Divided by 1 upon under root of h. हे या ठिकाणी राहील. 1 upon not under root of h. h raised to 3 by 2. हा पार्ट या ठिकाणी राहिलेला आहे. जर हा मी वरती घेतला तर काय होईल? h raised to minus 3 by 2 into dh. हा पार्ट आपल्याला या ठिकाणी भेटेल. म्हणजे हा पार्ट मी वरती नेला. So I get like this. Now do the integration of this. We know that if y is equal to x raised to n, then integration of this will be x raised to n plus 1 divided by n plus 1. Right. So I will do the integration of this minus 3 by 2 plus 1. What I will get here? 2 into 1, 2. So minus 1 by 2 I will get here. Right. So I will get here minus 1 by 2 and this part will remain as it is. Then I will put the limit inside this. Higher upper limit and lower limit. Both limits I will put there. Okay. And after putting this limit, now what we will get? Now see here, as this is minus 1 root here, so it will be don't vertical minus here, you can read it like this. And this, it can be written as 1 upon h raised to 1 by 2, or it can be written as 1 upon under root of h. Okay, so this is written like this. And then after that, limit has been put inside this h1 and h2, and you will get like this. हे लिमिट आतमध्ये पुट केली आपण, तर आपल्याला काय भेटेल 1 upon under root of h2 minus 1 upon under root of h1. This thing we will get here. So this is the first derivation or the derivation for the time required to empty the tank with the help of a rectangular notch or weir. Okay, I think you have written the title. Write down this formula directly in your notebook. T is equal to, write down this formula. After that, write down this title: time required to empty the reservoir or tank with triangular weir or notch. Is it what? Then this derivation, again, it is similar to the previous one. Let's define the terms: theta, CD, h1, h2 time. Okay. So again, the volume of water which is going to flow between the time dt, okay, it will be reducing the height dh, and if you multiply this dh by cross section area of the tank, tankचा हा वरचा area, that is a, and ही जी आहे depth आहे ती येत आहे. हा depth multiplied by area, you will get the volume minus ADH. Same principle here. Discharge into dt, right? The formula of discharge Q is nothing but this formula. For now, we are observing here triangular motion, right? So, between CD tan theta by 2 into 1 root of 2g into h raised to 5 by 2. This is the formula. So, we'll put this inside this equation. Then,
Sir, the negative value कशी काय आहेत?
yes,
Negative sign कसं काय आहेत?
मग सांगितलं negative sign is put here because volume is reducing, height is reducing there. पाणी बाहेर पडते टँक मधून, बरोबर आहे. पाणी टाइम जसा पुढे जाईल तसं पाण्याची जी डेप्थ आहे ते काय व्हायला लागते या ठिकाणी कमी व्हायला लागते, राईट. दॅट्स वाय दिस निगेटिव्ह साइन इज यूज्ड हियर. डेप्थ कमी होते आणि व्हॉल्यूम पण तेवढं कमी होते. ठीक आहे. Then this ADH is equal to this part which is come. Then again same thing, we have to take all other things here on the other side and we will get this dt is equal to this. Then total time t is obtained by integrating evaporation between the limit h1 to h2. h1 लिमिट पासून हाईट पासून ते h2 पाणी h2 जाईपर्यंत किती टाइम लागला, that is total time. So we have to integrate this equation between the limit 0 to t and h1 to h2. त्याचं इंटिग्रेशन आपण आता या ठिकाणी करणार आहोत. त्यातला जो कॉन्स्टंट पार्ट आहे तो इंटिग्रेशनच्या बाहेर येईल, जे व्हेरिएबल आहे ते आतमध्ये राहील. If you see here, the variable thing is only the h, that is head of water above the weir, right? That is h raised to -5/2. So now -5/2 as an integration जर केलं तर +1 divided by या part here. So 2 into 1, 2. So we will get here -3/2. So here you can see h raised to -3/2 upon 3/2. हे वरती जाईल इकडं म्हणजे 2/3 होईल, -2/3. मायनस मायनस कट होऊन जाईल, प्लस होऊन जाईल, राईट. अँड हिअर h raised to 3/2 जे ते काय आपल्याला डिनॉमिनेटर मध्ये पण आपण घेऊ शकतो. पॉवर जे इथे प्लस मायनसची या ठिकाणी खाली गेल्यावर प्लस होऊन जाईल. And when we put the limit h1 h2 to h2 here inside this, you will get this final equation. Okay, so write down this final equation after writing the title. Title लिहिले सगळ्यांनी. T is equal to 5a divided by 4 into cd into tan theta by 2 into under root of 2z square bracket मध्ये 1 upon h2 raised to 3/2 minus h1 raised to 3/2 1 upon h1. Is it over?
Yes, sir.
Now let us solve problem based upon this theory. Write on the problem. Find the time required. Find the time required to lower water level find the time required to lower the water level from 3 meter to 2 meter in a reservoir of dimension 80 meter by 80 meter of dimension 80 meter by 80 meter, comma, by a rectangular notch of length by a rectangular notch of length 1.5 meter 1.5 meter. Take CD is equal to 0.62. Write down the given things. Initial height 3 meter, that is h1 is equal to 3 meter. Final height 2 meter. Reservoir dimensions are given that are required for finding the area. Length of notch, CD, put all these values in the equation and find out the answer. Has anybody got the answer? Yes. Why this much time you are taking to solve this problem? Six hundred and 4.78 seconds. Okay. 605. 605.04, correct. How to convert that in minute seconds? मिनिट सेकंड मध्ये कसं कन्वर्ट करायचंय?
divided by 60.
त्याला 60 ने भागायचंय आणि जे व्हॅल्यू तुम्हाला त्याच्यामध्ये भेटतील पॉइंट मध्ये येईल उत्तर, त्याला परत 60 ने गुणायचंय. 605.04 भागिले 60. You will get 10.084. राईट. म्हणजे 10 हे आपल्याला मिनिट्स. 0.084 into 60, you will get seconds. That is 5 seconds. Are you getting my point? How to convert that in meter per minute and seconds? 60 ने त्याला डिवाइड करा आणि जे फ्रॅक्शन येतात त्या फ्रॅक्शनला परत 60 ने गुणायचं. Okay, shall we move ahead to solve next problem? टेकन. आता हे तुमचं 10.084 जे आलेलं आहे ते टोटल मिनिट मध्ये आहे. हे जे आलेलं आहे तुमचं 0.04 जे आहे त्याला 60 ने गुणाकार करा, मल्टिप्लाइड बाय 60, म्हणजे तुमचं सेकंड मध्ये येतील राहिलेले, जे 10 मिनिट आणि किंवा सेकंड मध्ये ठेवलं तरी ठीक आहे, काय प्रॉब्लेम नाही. Write down next problem. If in above problem, instead of rectangular notch, a right angled V notch is used. जर वरच्या प्रॉब्लेम मध्ये रेक्टँग्युलर नॉच ऐवजी जर व्ही नॉच वापरला असेल, राईट अँगल व्ही नॉच, then find the time required. Take all other data same. Yes. Solve this. Tell the answer. Is it possible to solve it, or any difficulties there? Has anyone got the answer? Okay. 7 minutes 50 seconds. So 3 students have got the answer right now. Ambarje, then Akasheva, and Rutuja. Let me check it. 7 minutes 49 seconds. Okay, correct. 469.3533. Correct. What you have got the correct answer. Other students put your answers. Okay. Now let us solve the next problem here. Right angled V notch. Right angled V notch is inserted inside of tank in a side of tank of length 4 meter and width 2.5 meter and width 2.5 meter. Full stop. Initial height of water above the apex of notch is 30 centimeter. Above the apex of notch is 30 centimeter 30. Find height of water above the apex. Find height of water above the apex, comma. If time required to lower the head, if time required to lower the head in tank from 30 centimeter to final height is 3 minutes. Take CD is equal to 0.6. So here time is given. Final height we have to find out. Initial height दिलेली आहे. H1 is given. You have to find out what is the value of H2. Solve this. Simple problem. Rearrange the terms. First put the values. Write down the given things. Yes. Has anyone got? This is the last problem here. Why this much time you are taking to find the answer? Okay, Aditya Avirakad has got the answer and Rituja. 0.08. 22 meters. Correct. 0.0822 meter is the correct answer. Only few students have got the answer. What about the others? आदित्य अगरखेड, ऋतुजा गवळी, अंबर जे, सुप्रभा आणि आदित्य अगरखेड. परत आदित्य पहिल्यांदा तुमचं उत्तर आलं 0.08. परत बदललं काय? गायकवाड 0.07.
0.079 मध्ये सर 8 आलं ना.
Okay, now this point is over here. Time required for emptying the tank. Okay, so now many students are putting answers, means it is understood by everyone. Those students who have not got the answer, we can note it down. H2 is equal to 0.0822 meter. So now let us move ahead toward the next point that we are going to see here. The title of that next point is broad crested weir. Okay. What is the meaning of broad crested weir? So in the classification we have noted down there, there are various types of the weirs based upon the size of the weir, size of the crest, and that are based upon the shape, I think. That are the sharp crested weir, then narrow crested weir, and broad crested weir. And last one is the Ogee weir. These are the various classifications. So depending upon the thickness of the crest here, or the width of the crest, here we have the three class: sharp crested, narrow crested, and broad crested weir. So when we call the weir as a broad crested, sharp crested, and narrow crested, so that thing we should know. So we'll note it down in your notebook. Write on the title: broad crested weir. First of all, definition of broad crested weir. A weir having wide crest is known as broad crested weir. Weir having wide crest is known as broad crested weir. Okay. Now, this thin plate or sharp crested weir means what? That values we should know ratio. So write down there. If write on this ratio, H by B greater than 1.6. If H by B, H is the head of water ivory crest and B is the width of the crest. If H by B is greater than 1.6, हेड जास्त आहे, width कमी आहे त्या केस मध्ये, then it is known as thin plate weir. Then it is known as thin plate weir. Next, if, write on this, if h by b is greater than or equal to 0.4 but less than or equal to 1.6, if h by b, that is head to width ratio, हा या ठिकाणी कमी झालाय आता, मगाशी जास्त होता आता थोडा कमी झाला, greater than or equal to 0.4 but less than or equal to 1.6, then it is known as narrow crested weir. Is it over? Last one, if again याच्या ठिकाणी रेशिओ कमी झालाय 0.4 पेक्षा पण कमी, म्हणजेच काय h ची व्हॅल्यू खूप कमी आहे ऍज कम्पेअर टू दी width, right on there. h by b is greater than, less than, greater than or equal to 0.1 but less than or equal to 0.4, it is known as broad crested weir. If h by b ratio is greater than or equal to 0.1, less than or equal to 0.4, then it is called as the broad crested weir. This is the diagram of the broad crested weir. You can show it. Diagram तुम्ही त्या ठिकाणी काढू शकताय. ब्रॉड क्रेस्टेड weir मध्ये जर अप्पर एज हा असा शार्प असेल तर या ठिकाणी एअर पॉकेट तयार होतो, लाईक दिस. ओके, टू अवॉइड दिस एअर पॉकेट आपण याला ब्लंट करायचं. ओके, एअर शार्प एज जो आहे तो काय करायचा या ठिकाणी ब्लंट करायचा. या ठिकाणी कर्वेचर प्रोव्हाइड केलं तर दिस इज अ राऊंड कॉर्नर, इट बिकम्स राऊंड कॉर्नर. जर असं असेल तर या ठिकाणी एअर पॉकेट वगैरे तयार होत नाही. ब्रॉड क्रेस्टेड weir with sharp corner as upstream. Broad crested weir with round corner at the upstream end. Is it over? Now here we have to note down the formula for the discharge over the broad crested weir. Write down the formula. If L is the length of crest of the weir, if L is the length of crest of the weir, over the weir, then what is capital H? डायग्राम मध्ये तुम्ही दाखवलेले कॅपिटल एच आणि स्मॉल एच. ओके. Then discharge over broad crested weir is given as discharge over broad crested weir is given as capital Q is equal to L into H into under root of 2Z capital H minus small h. Okay. If the CD value is known, coefficient of discharge or plummet cell, then you can find out the actual discharge. So write down their formula for actual discharge. Q actual is equal to Q actual is equal to CD into L into H. CD into L into H under root of 2Z bracket capital H minus small h. Okay. Our next point is spillway. Okay. Write on the title spillway. What is the meaning of spillway? Once again.
It is the part of dam which is constructed for the removal of extra water
Correct.
when reservoir is full.
Correct. It is the portion or it is the part of the dam itself, or it will be provided separately for the purpose of draining out the excess water from the reservoir. Right? So that is called as the spillway. मराठीत आपण त्याला सांडवा म्हणतो. Spillway, it may be provided in the dam itself, in the body of dam, or it may be provided separately. So now tell me, in which condition we provide the spillway in the body and out of the body? Can anyone?
Earthen dam out of body.
Correct. Earthen dam cell, in that case, we provide the spillway separately. Right. Suppose this is the river. This is the dam provided here. Then spillway will be separate, provided at the side of the dam itself, or it may be provided some away from the dam body, so that excess water it will spill out here and it will join the downstream side of the river. And in case of concrete dams, okay, gravity dams, the spillway is provided in dam body itself, right? Up to the FRL level, water will be stored in the dam itself, in the dam, full reservoir level. Beyond that, the water is the excess water. That water has to be drained out from the dam, and this water, excess water, it will flow over the this portion, dam portion or the weir portion. Okay. And this is the main function of spillway, right? A spillway is a portion of a dam over which the excess water which cannot be stored in the reservoir formed on upstream of the dam flows to the downstream side. Okay. In general, shape of the spillway profile is made of the follow the profile of the lower nappe of the well ventilated sharp crested weir. Right. So there are different types of spillways. Here we are going to study what is the Ogee spillway. Okay. You can see here the shape of the spillway is this Ogee spillway. Ogee is nothing but it is S shape. Ulta jaise S. S shape spillway by that is called as the Ogee spillway. Okay. So let us write down here title spillway and write down there spillway is a portion. Definition le. Spillway is a portion of a dam spillway is a portion of a dam over which excess water over which excess water which cannot be stored over which excess water which cannot be stored in the reservoir formed on upstream side formed on upstream of dam flows to the downstream side. Flows to the downstream side. Title yeah, Ogee spillway. Draw this diagram. Ogee spillway. Okay, have you drawn the diagram? Then discharge over Ogee spillway. Write down the sentence. Ogee spillway has Ogee shape or S shape. Right? And this sentence is important. The main advantage of this providing such shape for spillway is that flowing sheet of water remain in contact with the surface of spillway, thereby preventing the negative pressure being developed on the downstream side. The flowing water है, sheet of water, it should be remain in contact with the surface of spillway. Spillwayच्या कॉन्टॅक्ट मध्येच असलं पाहिजे. जर कॉन्टॅक्ट तुटला तर त्या ठिकाणी निगेटिव्ह प्रेशर तयार होऊ शकतो आणि जर निगेटिव्ह प्रेशर तयार झाला तर त्या ठिकाणी कॅव्हिटेशन तयार होऊ शकतं. कॅव्हिटीज मे फॉर्म आणि कॅव्हिटी जर त्या ठिकाणी ब्रस्ट झाल्या तर तो जो वियर सरफेस आहे त्याची वियर अँड टियर त्या ठिकाणी जास्त होऊ शकते. राईट. इज इट ओव्हर? Then write down the equation for the discharge. The discharge over spillway, discharge over an Ogee spillway. Discharge over Ogee spillway, like this. Discharge over an Ogee spillway may be expressed as Q is equal to C into L into H raised to 3/2, where C is the coefficient of spillway, L is the length of spillway, and H is the head over the crest of the spillway. The coefficient C of spillway may be determined by calibration. Last point here, calibration of rectangular weir or notch. Let me check whether it is the last point or anything else is remained. Okay, so this is the last point here now. That is the title, calibration of rectangular weir or notch. Calibration of rectangular weir or notch. Okay. Now calibration म्हणजे काय आपल्याला सगळ्यांना माहिती आहे. To find the constants of that particular devices, right? That is nothing but calibration, right? A rectangular weir or notch is generally used for measuring the quantity of water flowing in a channel, in which case it must be calibrated previously. अगोदर कॅलिब्रेशन केलेलं असलं पाहिजे म्हणजे त्याच्या कॉन्स्टंटची व्हॅल्यू आपल्याला माहित पाहिजे. For this purpose, the weir or notch which is to be calibrated is installed in the laboratory channel. And discharge, कसा discharge आपण त्या ठिकाणी मेजर करतो, हेड मेजर करतो. ओके, discharge equation may be expressed as Q is equal to K into H raised to N. जे आपल्या रेग्युलर मेथड आहे त्या रेग्युलर मेथडने आपण त्याचा डिस्चार्ज ऍक्च्युअल डिस्चार्ज मेजर करायचा. ओके, हेड त्याचा मेजर करायचा. Discharge Q can be expressed by using this equation. या इक्वेशनची आपण दोन्ही साईडला जर आपण लॉग घेतला तर आपल्याला इक्वेशन भेटते लॉग क्यू इज इक्वल टू लॉग के प्लस एन इंटू लॉग एच ही इक्वेशन आपल्याला या ठिकाणी भेटते. So these are the equations of straight line log q log h, okay, which is a straight line log in terms of log q and log h, right? Now calibration करतो म्हणजे काय करतो आपण या ठिकाणी we find the value of k and n. k आणि n ची व्हॅल्यू एकदा आपल्याला माहित झाली तर मग आपण या ठिकाणी डिस्चार्ज इझिली फाइंड आउट करू शकतो. जस्ट फाइंडिंग द h हेड फक्त या ठिकाणी फाइंड करायचा म्हणजे आपल्याला त्या ठिकाणी डिस्चार्ज भेटू शकतो. नाउ आफ्टर अप्लाइंग दिस लॉग हियर, एक लॉग पेपर वरती आपण याचे व्हॅल्यू पुट करायचे. ओके, एक्स ऍक्सिस वरती ऑन द ऑर्डिनेट अँड ऑन ऍब्सिसा. ऑर्डिनेट वरती काय घ्यायचं, ऑर्डिनेट म्हणजे वाय ऍक्सिस वरती त्याचे व्हॅल्यू निगेटिव्ह असतात त्यामुळे हा ग्राफ आपला इथून येईल. ऑर्डिनेट वाय ऍक्सिस वरती येईल त्या ठिकाणी लॉग क्यू. ओके, for example data plot log q as ordinate and log h on the abscissa. Log h हा या ठिकाणी असेल. ओके, which will be a straight line in the accordance with the equation 1. ज्यावेळेस एक पॉइंट आपण प्लॉट करतो त्यावेळेस आपल्याला असे एखादा कर्व भेटतो, स्ट्रेट लाईन भेटते. ओके, the value of k and n may be obtained determined from the plot as described below. आता या ठिकाणी ज्या पॉइंटला ही लाईन कट करते लॉग क्यू ला, दिस व्हॅल्यू इज नोन ॲज द व्हॅल्यू ऑफ के. ही जी व्हॅल्यू आपल्याला भेटते ज्या ठिकाणी कट केलेला आहे दॅट इज नथिंग बट के व्हॅल्यू. ओके, फॉर h इज इक्वल टू 1 लॉग h इज इक्वल टू 0. जर h इज इक्वल टू 1 आपण टाकलं तर लॉग h ची व्हॅल्यू काय येते 0 होते. म्हणजे या लाईन वरती आपल्याला log q will become equal to log k. ओके, म्हणजे हा पॉइंट आपल्याला भेटला. फर्दर या इक्वेशन मध्ये आपण जर रिअरेंज टर्म्स केल्या log k आपण इकडे घेऊन गेलो तर काय येईल log q minus log k आणि हा पण पार्ट इकडे घेतला तर डिवाइड होईल log q minus log k divided by log h. यास आपल्याला भेटेल n is equal to. ओके, तर log h ची पण आपल्याला व्हॅल्यू माहिती आहे, log k ची माहिती आहे, log q ची माहिती आहे. If you put this value in this equation, you will get the value of n. Okay, and once you get this value of n and k, so that is nothing but calibration of this weir, rectangular weir. So this was about this calibration of the weir. You can note it down their equation like this. The discharge Q may be expressed as Q is equal to K into H raised to N by taking log on both sides of this equation. We get this equation log Q is equal to log K plus N into log H. Give this equation number 1, which is a straight line log in terms of log Q and log H. From the experimental data, a plot of log Q as ordinate and log H on abscissa may be prepared, which will be a straight line in accordance with equation 1. And at last, the values of K and N may be determined from the plot. The values of K and N may be determined from the plot. Okay. So this is the end of this unit and end of the syllabus. We have finished this syllabus now. Now we have the time yet. So we will solve some problems. If you wish, we will solve problems from this unit. जे आपले राहिलेले आहेत किंवा आपल्याला सोडवायचे आहेत. याच्यावरती आपण 3 प्रॉब्लेम घेतले होते. Weir and notch वरती. Let us solve this problem. Write out the problem. Determine the height of rectangular weir of length 6 meter. Determine the height of rectangular weir of length 6 meter to be built across a rectangular channel. Rectangular weir ची height जी आहे त्याला फाइंड आउट करायची. The maximum depth of water on upstream side of weir is 1.8 meter. And discharge is 2000 LPS. Discharge is 2000 LPS. Take CD is equal to 0.6 and neglect end contraction. And left end contraction. Read the problem. See, we have to ask to find, it is asked to find height of the rectangular weir. The height करायची, first height means this H2 काढायचं. दिले का आपल्याला maximum depth of water on the upstream weir is 1.8 meter. पाण्याची जी लेवल आहे height maximum आहे H1 and this H1 is nothing but 1.8 meter. Okay, and this is the head. Over here. Now this head of the water above the weir plus height of the weir, you will get this total depth of water. Okay. Now we need to find out this H2. I have told you काय करायचं मी तुम्हाला सांगितले. कसं करायचं कोण सांगेल? Yes, can anyone? कोण सांगितलं का? How to find this H2? Shruti. अनिशा, कोण सांगेल? शुभांगी उंबरजे,
CD into L into small h into under root 2G into h minus small h.
once again repeat.
CD is into L into small h into under root 2G into bracket h capital H minus small h.
Okay, what we will get there? What we will get? Whether we will get H2 or capital H? H2 भेटेल का capital H भेटेल?
Capital H.
Correct. See, once you get this capital H, then it is quite simple. Just subtract this capital H from this H1 and you will get the value of H2. That is depth of height of the weir. You will get it. Is it simple? Now here your task is to first find out what is the capital H. Discharge तुम्हाला दिलेला आहे. Right. So use that formula and find out the capital H. And once you get this capital H, subtract it from the H1, that is 1.8, and you will get the value of H2. Everyone understood this? Shruti, have you understood?
Yes.
Okay. Solve this and tell me the value of H2. आपली थेअरी संपलेली आहे, प्रॅक्टिकल आपले राहिले आहेत, ते प्रॅक्टिकल आपण उद्या कंप्लीट करणार आहोत. तर जे विद्यार्थी फिजिकली प्रेझेंट राहू शकतात ते विद्यार्थ्यांनी कॉलेजवरती यायचं आहे उद्या सकाळी. टुमॉरो वी विल कंडक्ट, I think in the morning session CT practicals are there. If sir is not going to conduct, then I will conduct the practical. मधल्या स्लॉट मध्ये तर आपलं प्रॅक्टिकल आहेच, त्या स्लॉट मध्ये आपण राहिलेले प्रॅक्टिकल संपवणार आहोत. ओके, त्यातले 2 प्रॅक्टिकल आपले डेमॉन्स्ट्रेशन टाइप आहेत, जस्ट एक्सप्लेनेशन इज रिक्वायर्ड, आणि बाकीचे जे 2 प्रॅक्टिकल आहेत त्याच्यामध्ये आपण ऑब्झर्वेशन वगैरे घेणार आहोत. सो जेवढ्या विद्यार्थ्यांना शक्य आहे, दे स्टुडंट्स दे कॅन कम टू द कॉलेज tomorrow. And tomorrow we are going to end the practicals also. तुमचे एमसीक्यू टेस्ट किती झालेले आहेत? काल मी एक एमसीक्यू टेस्ट टाकली होती, सगळ्यांनी अटेम्प्ट केली?
Yes, sir.
Let me check it. Gopur has got the answer. Sandeep Pawar, Gopur 0.0, 0.328. Okay. Let me check it. H1 is equal to 0.357. Somewhere mistake is might be there. चेक करा, उत्तर वेगळं दिसतंय. Determine the head of water. H2 इज इक्वल टू, हा तुम्ही H काढले आताशी, बरोबर आहे, ठीक आहे. H2 काढायचं, H2 काढा तुम्ही. तुम्ही कॅपिटल H काढलेलं बरोबर आहे ते. H2 is equal to 1.472 ऋतुजा. Let me check it. H2 is equal to 1.47. Correct. We have got the correct answer. युनिट नंबर 6 ची तुम्ही MCQ 46 विद्यार्थ्यांनी MCQ अटेम्प्ट केलेली आहे. ठीक आहे. अजून तुमचे 1 2 3 तीन युनिटची MCQ टेस्ट राहिलेले आहेत. So within these 2-3 days, I will put this MCQ test in your group. You have to attempt that, right? ज्या विद्यार्थ्यांनी MCQ टेस्ट दिलेले नाहीयेत त्यांच्यासाठी मी एक विंडो ऑफ ऑपॉर्च्युनिटी त्या ठिकाणी क्रिएट करतोय. संडेला तुम्हाला मी वेळ देतो, ठीक आहे. ऑन संडे आय विल ओपन ऑल द लिंक्स, जे काही MCQ टेस्टचे जे लिंक आहेत, जे फॉर्म आहेत ते सगळेच ओपन करतो. ज्यांचे राहिलेले आहेत त्यांनी ते अटेम्प्ट करा, बिकॉज ते मार्क तुमचे काउंट होणार आहेत. तुमचे ICA चे जे मार्क आहेत, ISE किंवा ICA एखाद्या ठिकाणी तुमचे मार्क्स काउंट होणार आहेत. मार्क टर्म वर्क मध्ये वगैरे ते काउंट होऊ शकतात. सो जर तुम्ही टेस्ट दिले नसतील तर द्या, अदरवाईज तुमचे मार्क त्या ठिकाणी मिस होऊ शकतात. ठीक आहे. सो वी कॅन अटेम्प्ट इट. काही टेस्ट हे 20 मार्काचे आहेत, काही 10 मार्काचे आहेत. व्हेरी स्मॉल टेस्ट आर देअर. विदिन 10 minutes यू कॅन अटेम्प्ट द क्वेश्चन्स. On the Sunday, up to Sunday, you have to complete all these assignments. Not assignments, that MCQ test you have to complete. It is compulsory to all. Yes, put your answers in the chat box. Only Vedanta and Rutuja has put the answers. What about the others? Kekan, Kekan, are you there?
Yes, sir.
Are you solving problem or not?
Yes, sir.
Aditya Agarkhed,
Yes, sir.
Sandeep Pawar, are you solving problem?
Yes, sir.
You solve it first. 30 आणि 31 ला तुमचे ओरल आहेत, सर्वे आणि FM चे. पहिल्या दिवशी तुमची सर्वेची असेल 30 तारखेला. शेड्यूल तुम्हाला आलेला असेल बहुतेक. तुम्हाला त्याचे जे क्वेश्चनचे जे आहेत, ठराविक क्वेश्चन जे विचारले जाऊ शकतात, ते क्वेश्चन्स तुम्हाला मी प्रोव्हाइड करतो. सो आता हा प्रॉब्लेम झाल्यानंतर तुम्हाला मी काय करतो, ते क्वेश्चन जे आहेत ते क्वेश्चन या ठिकाणी डिस्प्ले करतो. तुम्ही नोट डाऊन करा किंवा त्याचे स्क्रीनशॉट काढून घ्या. त्यासाठी टेस्टसाठी, तुमच्या ओरल साठी जे प्रश्न आहेत ते त्याच्यासाठी. Okay, those students who have not got the answer, please note it down in your notebook. H2 is equal to 1.472. Now I am going to dictate you the MCQ questions which may be asked in your oral examination. You can note them these questions in your notebook. So all of you note down the questions. For the practical number 1,
सर स्क्रीन विजिबल नहीं क्वेश्चन.
can note down these questions. What is hydrostatic pressure? What is formula to find hydrostatic pressure? What is Pascal's law? What are the practical applications of Pascal's law? What is mathematical expression of Pascal's law? Are you taking the screenshot or writing?
Writing, sir. Give the broad classification of devices used for measuring pressure. What are main two types of the manometers? What are various types of mechanical gauges?
What is meant by least count of gauge? What is gauge pressure? What is atmospheric pressure? What is vacuum pressure? What is the value of atmospheric pressure in terms of mm of Hg and meter of water? What is the difference between simple and differential manometers? Then difference between differential and inverted differential manometer. Is it over? Then what is pressure head? What are limitations of piezometer? What is specific gravity of mercury? Why mercury is used as a manometric fluid? What types of fluids is used? What type of fluid is used in inverted tube manometer? What is the rate of flow? What are formulae to calculate the charge? How to measure discharge using measuring tank? What is unit of discharge? What is continuity equation in its simplest form? On which law continuity equation is based? Determination of metacentric height. What is metacenter? What is metacentric height? What is Archimedes principle? What is center of buoyancy? Theoretical formula to find metacentric height. Experimental formula to find metacentric height. What is stability condition of a floating body? What is stability condition of a when submerged condition is considered as in stable equilibrium? Practical number 3, verification of Bernoulli's theorem. Which main 3 forms of energies are considered in fluid flow? What is pressure energy, kinetic energy, potential energy? What is pressure head, velocity head, and potential head? What is total head? What is statement of Bernoulli's theorem? What are assumptions involved in the Bernoulli's theorem? On which law Bernoulli's theorem is based? What is Bernoulli's? What is statement of Bernoulli's theorem? What are assumptions involved in the Bernoulli's theorem? What is Bernoulli's equation? What is modified Bernoulli's equation? What are the practical applications of Bernoulli's theorem?
How to measure pressure head in practical? How to measure or calculate velocity head in practical? Shape of horizontal pipe. Is it uniform or tapered? What type of curves can be observed in piezometer? Is it over? Roll number 20, Rupesh. Rupesh, what are you doing? Calibration of venturometer. Which quantity is measured with the help of venturometer? What is coefficient of venturometer or coefficient of discharge? How actual discharge is measured? What is formula to calculate theoretical discharge? What are the components of venturometer? What is the included angle of convergent cone of venturometer? What is the range of included angles of divergent cone of venturometer? How h in the Q theoretical formula is calculated? What are the 4 cases to find h? What is the range of CD for venturometer? CD of venturometer is greater than or smaller than that of orifice meter. Calibration of orifice. What is an orifice? Types of orifice based on shape. What is small orifice and large orifice? How CD of orifice is calculated? How to measure actual discharge? What is formula to find theoretical discharge? What is H in the Q theoretical formula? How it is obtained? What are hydraulic coefficients of orifice? What is the relation between CD, CV, and CC? How CV is calculated in experiment? What is X and Y value in CV formula? What is vena contracta? What are the ranges of CD, CV, and CC of orifice? Next, study of factors affecting coefficient of friction. What are the 2 main head losses occurs in the pipe flow? What is major loss or head loss due to friction? Which property of the fluid is responsible for head loss due to friction? What are the formulae used to find head loss due to friction? Tell Darcy-Smith equation. What is F in Darcy-Smith equation? What is the relation between coefficient of friction and friction factor? What is modified Darcy-Smith equation? What is Chase's equation? What is C, R or M or S by N in Chase's formula? How to calculate hydraulic radius or HMD? How hydraulic gradient is calculated?
Chase's formula is mainly used for pipe flow or open channel flow. How head loss due to friction is calculated in practical? What are the various types of major losses? Study of laminar flow. हा practical आपल्यात नाही आता include. So it is so. जे आता नवीन ऍड झालेले प्रॅक्टिकल आहेत त्यांचे क्वेश्चन्स तुम्ही स्वतः त्या ठिकाणी तयार करा. 6 प्रॅक्टिकल जे आहेत टोटल त्यापैकी 6 आहे तुम्ही तुम्हाला दिलेत क्वेश्चन. So now, if you are having any doubt or query, you can ask me. Okay, if no one is having any doubt, now shall we stop here? Tomorrow, you have to come to the college. जेवढ्या विद्यार्थ्यांना शक्य आहे त्यांनी या. ते राहिलेले प्रॅक्टिकल आपण परफॉर्म करूया त्या ठिकाणी. टिल्टिंग फ्लेम वरती आपल्याला 2-3 प्रॅक्टिकल घ्यायचे. So you will come to know that in diploma you might not have performed the practical on the tilting flume due to the lockdown. Due to the lockdown, you might not have performed the practical on the tilting flume. So you will get idea about what is tilting flume, how it works, what are the various practicals that can be performed on the tilting flume. Okay. So those students, hostelite students, they must come here for performing the practicals. So if you don't have understood any concept from this fluid mechanics, you can ask me at any time. I will explain that concept to you. You can come to the college, to the department, to ask the question queries regarding the fluid mechanics, and you can ask me. I have put all the notes. प्रत्येक युनिटच्या नोट्स हे टाकलेले आहेत. तुमच्या टीचिंग डायरी मध्ये टाकलेले आहेत. ओके, त्या नोट्स तुम्ही डाउनलोड करून घ्या, चा अभ्यास करा. आणि एमसीक्यू टाइप जे क्वेश्चन आहेत ते क्वेश्चन पण तुम्हाला जे दिलेले आहेत त्याच्यावरती दॅट आर नॉट सफिशियंट. टेस्ट आपण जे घेतलेले आहेत तुम्हाला याच्यावरती गुगल वरती भरपूर प्रमाणामध्ये एमसीक्यू टाइप क्वेश्चन भेटतील. ते डाउनलोड करा, त्याचा अभ्यास करा. Okay, to get the more mark, you have to do a lot study. Passing will be somewhat easy, but to score it is difficult. ज्यांना स्कोर करायचे, चांगले मार्क पाडायचे, they have to do more study. So if no one has having any query, then shall we close now? Shall we close this session? Okay, let me take your attendance first. Attendance घ्यायची राहिलेली आहे. I have taken your attendance. Now you can leave the session. Mayur, what is the name? Mayur Shende.
Yes, sir.
What are you asking? Oral साठी फक्त 6 प्रॅक्टिकल्स आहेत का? Yes.
Yes, sir.
हा प्रश्न कसं काय आला तुम्हाला तुमच्या डोक्यामध्ये? का प्रत्येक गोष्ट आपल्याला शॉर्ट करूनच पाहिजे, प्रत्येक ह्याच्यामध्ये कन्सेशन पाहिजे? Yes. Mayur Shende,
Sorry, sir.
this approach is not good.
Sorry, sir.
See, असा जर अप्रोच ठेवला तर आपण जीवनामध्ये पुढे जाऊ शकत नाही कधीच. Mayur Shende, what do you want to become after completion of this civil course graduation?
Sir,
कशासाठी? Yes.
I want to crack a GATE exam.
Which exam?
GATE exam.
गेट एक्झाम. आणि तुम्ही प्रत्येक ठिकाणी शॉर्टकटचा विचार करताय. कशी गेट क्रॅक व्हायची तुमची? तुम्ही कुठल्या एखाद्या विषयाचं पुस्तक अभ्यासाला वापरलंय का? अभ्यास करताय का? पुस्तक नाही केले का तुम्ही? रेफर करताय सब्जेक्ट साठी?
सर मी सॉलिड मेकॅनिक्स करतोय स्टडी.
कुठलं बुक वापरताय? कोणतं?
मेडिझी UC जिंदल.
मेडिझी.
येस सर.
ओके, एकच विषयाचं करताय का अभ्यास?
हा सध्या तरी एकच चालू आहे.
आता तुम्हाला 5 विषय आहेत ना सेमला? किती आहेत? 4 का 5? हे सगळ्या विषयांचा अभ्यास केला तर तुम्हाला ह्याचा विद्यापीठाच्या परीक्षेला पण फायदा झाला असता त्याचा. See, if you want to crack the GATE exam, then you have to think broadly. ओके, जेवढं तुम्हाला शक्य आहे तेवढं तुम्ही जास्त डीप मध्ये स्टडी केला पाहिजे. शॉर्टकट वापरायचं नाही कुठल्याला.
येस सर.
कोरोनाचं एक आपल्यासाठी आता कारण झालेलं आहे. पण एक इंग्लिश मध्ये प्रोवर्ब आहे, जे माणूस विनर असतो, विनर्स डोंट हॅव द रिझन्स टू टेल, आणि जे लुजर असतात त्यांच्याकडे बरीच कारण असतात सांगण्यासाठी. ओके, तर त्याच्यापैकी एक कारण की आमचं ऑनलाईन होतं, लेक्चर्स ऑनलाईन झाले कोविडच्या याच्यामध्ये, काय बरेच आपल्याकडे कारण असतात सांगायला. So that kind of reasons should not be told by you. Yes, I have told you, you can leave the meeting. I have taken your attendance. Those students who want to leave, you can leave the session. With this roll number 53. Roll number 53. Okay, shall we close the session now?
Yes, sir.